maybe while Michael is sorting his setup, if everybody would like to, I have two Michaels here. Tell us where you are and what you're doing today. Is it going to be a lunch stream for you? Is it going to be an early morning stream for you? Is it going to be an afternoon stream? San Jose, so that's definitely early morning.
It's super early morning.
Yes.
Good morning, Konrad.
Good morning, Konrad. It might be a very good start to your to a Monday morning, or you you just can't
God.
sleep at all.
Insomnia stream, I guess.
Exactly.
Right? Welcome, Konrad. So I hope that's will be fun and useful today. Please, everyone, bring your questions. We're more than happy to answer anything that can help you getting familiar with data. And so you're like me, Konrad. Sounds very familiar.
Sleep.
But you also have to get up at 6:30 in the morning to get the kids to school. Also. That's when my alarm clock rang this morning.
Oh wow! All right. Yeah. So the goal of this stream, again, we will dive in a more or less random data set. It's not that random this week. We picked it a little bit on purpose here, but we will dive into it. We will do some modeling with arrows. We will import the data, load it with CSV into an Aura-free instance. If you don't have an Aura-free instance ready, please go ahead and launch that for you. This is the link in the chat right now. I posted it earlier as well, and then we can load some data, do some queries, and play a little bit with the data. But as always, this is supposed to be interactive. So if you have any questions, if anything you'd like to know, anything, obviously in our discussions on the data set, on our modeling thinking, let us know what you think, and let us know what you would do differently maybe, or what your suggestions would be. Yeah. Shall we dive in, Michael?
Yeah, let's get started. So let me start sharing my screen. And then we get going. Hope you can all see this. So we have something really important coming up in Germany in 2 weeks. On September 26th, we have our general election, 4 years since the last one, and lots of important topics on the table, especially climate change, the future of the world, and how it's going to be for our kids and everyone. So what's actually quite cool is in Germany.
Do you want to go to present mode?
Yeah, I can do that. 1 second.
Yep.
Well, let me pull this into a separate tab so I can switch between this and the other one. Okay, so we have election year, and we're all in for election. So actually, we already did mail-in voting already, my wife and I. So what's actually cool in Germany, there's this program from the government. It's called Wahlomat, which is kind of like an election omat, which allows you to look at the different parties and their stances to a number of topics. And you can put in your own stance to each topic and then compare yourself with the party. So I can show you what this looks like. So you go basically here. And unfortunately, it's only in German, but you get basically 38 topics. And you can say, okay, I am for general speed limit on highways. Yes, right? And so on. So you get like all these questions, and then at the end, it compares your answers with the stances of all parties. So they went through all political party programs and extracted all the data. And so you can compare them and say, hey, I'm closer to this party or this party or this party. And you can also select a subset of parties and so on. So it's pretty cool. So if you're in Germany or interested in that, and if your German is good enough, but it even works if Google Translate, could try this out. So what's actually quite cool is they also provide their data. So you can download the whole app to run it locally if you have like a school which is off the internet or something like that, and you want to offer this for your students or so. But you can also just download the data itself, which is a zip file with an Excel sheet. And I basically just took this Excel sheet and extracted it into the CSV. So what we want to do today is basically taking this data from this app, turning it into a graph, exploring it, playing around with it in Aura Free, and see how far we can get here. And of course, if you have questions that we can try to answer, then feel free to bring the questions, and we'll try to make this happen and as interactive as possible, as Alex said.
We have a good question already from Rodolfo. He's using a Neo4j Community Edition, and he would like to know what the difference between Neo4j Aura and the regular Community Edition is. So I think that's
a good one that we can actually start with. Basically, or give me a second, and then we get there on the Aura slide. So basically, we want to kind of explore this. Then, if you have not used graphs before in a graph database, basically what you do is you store not just the entities and their attributes, but the connections or the relationships between the entities are stored as first-class citizens in the database as first-class data structures. So you don't need to compute them at query time with joins that are looking up data from indexes, but it's basically part of the data and the data model. And so it's pretty versatile. So you can store everything from social networks to purchase, to interaction networks, to hierarchies, to student curriculums in universities, investigative journalism, bills of materials for aircrafts or other things. So it's pretty flexible, even for election data. And so Neo4j is kind of a graph database built for exactly this purpose. And you can use it both on the transactional side, building applications that use Neo4j, but also on the analytics side, if you want to really use it as a graph analytics platform and graph data science platform. And we have a lot of stuff around it, from tools like Neo4j Browser, which you'll see, but also drivers for all kinds of languages, and a lot of additional integrations and connectors for Spark, Kafka, and so on. So there's a lot of stuff there. And what we want to look is into Aura. And for Rodolfo's question, to compare Aura with Community Edition, actually, I think there's even a comparison page. Let me see if that's, I think it's somewhere here on the comparison page. Let's see. Oh, that's just between the different.
Yeah.
So the main differences between Community Edition and Aura is it's hosted by Neo4j. You don't need to do any maintenance operations, upgrades, backups, and things like that. So all of that is taken care of. You always have the latest version. And with Aura Free, you start out for free, and then you can scale up your needs according to your needs from that. And on Aura, it also runs Enterprise Edition, so you get all the features of Enterprise Edition, some of the features of Enterprise Edition, depending on the tier. Like, for instance, better Cypher runtime is part of this offering. Certain functions procedures are there that are not part of Community Edition. And so that's mostly the kind of ease of use, and you don't need to maintain host and manage it yourself, and you get like the good runtime and things like that from that.
And you also get Bloom.
And Bloom is also part of that, exactly. Yeah. It's securely stored, and you can start out for free, and then if you scale up to a more production usage, then you can scale from 1 gig to 64 gigs in professional on the fly without any downtime. So you get all the updates and all the scale and migrations without that downtime, which is also really nice. I hope this answered your question, Rodolfo. If you have more questions, please bring it on. But there's this Cloud Aura pricing page that kind of has more details on each of these offerings.
But it's basically Enterprise Edition in the cloud.
Enterprise Edition, exactly.
Yeah. Conrad wants to know what's the default password. As far as I know, you need to set that yourself.
Yeah, so let's see. I'll show you in a second. So actually, that's something I wanted to show, which is when you get started in Aura, you go to console.neo4j.io, log in, and you have to accept terms and so on. And then you have to choose between Aura Professional or Aura Free. We're going to do an Aura Free. and just give it a name. And then you say create free. You can also select a region. Say create free database. And here it shows you the password. And this is something that you have to copy and save. Otherwise, you need to reach out to support to reset the password. So that's why it also says, I've stored these credentials safely to use later.
Yeah, and if you forgot to store them, then and have nothing loaded, then just redo.
Yeah. So if I click continue, it starts creating this database. And it takes a few minutes to provision it. So you have to do it before you're going to join us. But if there's something wrong and it's still empty and you have not done anything, or if you just want to get rid of it, there's under settings, you can just delete the database and then start over. So it's not a big deal because it's free anyway, so it doesn't matter. Okay, so it takes a few minutes to provision. That's why, meanwhile, we can go back to our setup here. So what we do is we take the CSV, and the CSV is basically available from this download page, as I already mentioned, and it's a zip file with actually an Excel sheet. I have to update this because this was the previous Excel sheet. And I extracted this, and it's on GitHub. So if you want to see this data, then you can just go here on GitHub, and we have all the data in the CSV here. Unfortunately, it's not nicely rendered on GitHub because it's too large. But anyway.
But we also, as in the sessions before, we always collect the information, the queries, and all the information on our GitHub repository page. So we'll be able to read this up afterwards.
Exactly. So if you go to dev.neo4j.com BTW Bundestagswahl BTW 21, then this gets you to the today's section, and this has like the data modeling queries and also the link to the data as well.
Yeah, and I'll post a link in the.
So we basically start by looking at the CSV. So the CSV has three parts. One is the party with a number, a name, and a short string, basically, or a description. And then the thesis or the topic has also number, title, and text, right? So obvious. And then the position is basically the stance of the party towards this topic, right? So either they agree, they are neutral to it, or they disagree, right? And then an explanation why they agree or disagree to that. And so that's basically our data. So it's a single CSV, all the data is in there, and each row of the CSV is representing basically one of these positions of a party to a topic. So the parties are duplicated and the topics are duplicated in the CSV as such, right? So what would our model look like for something like this? So to do this, you can go to arrows.app. And Arrows app is a really nice modeling tool that you can use with Neo4j. It also exports to Cypher if you want to. And usually you can do two different levels of modeling. Either you do an instance modeling, so where I say, for instance, you take a party, like this party, and then you can drag a relationship basically out of the halo of a node, like this. And here the topic would be, for instance, speed limit or something like that, right? So this would be kind of our instance model, right? And then position would be something like yes or no, right? And then we have attributes and labels. So this is kind of an example model. And then we can say, okay, to this example here, we want to add a label, which is, for instance, a party. Right? And here's a topic. So these are our two entities, basically, in our graph. And then we can have attributes for these. So I said they have like an ID or number, which is an int. They have, they have an ID, they have an name, which is a string. And the party as well, it has an ID, and it has a name, and it has a description, right? And then our position should get something like a weight, right? So in the original text file, it's in textual. I agree, I don't agree, I'm neutral, basically, but we want to turn this into a numeric value from 0 to 1, basically 0.5 and 1. So that's kind of our model that we're looking at, right? So we basically have a body, a topic, and a position with a weight against that. And so basically we take the CSV and turn this into this model, right? So there could be different approaches for modeling these. For instance, you could say, okay, I want to pull out the position into a separate node and attach more information to that. For instance, I don't know, links to the party program or, other things as such. But for our needs, this simple model is good enough as such, right? So
yeah, this is a more of a simpler model this time around, because obviously it's not too complicated, but it's but it it's
but
still,
you can imagine you would kind of try to build a knowledge graph from this. Then you would kind of connect the topics to additional information or to additional sources or things like that, or discussions, or you could connect the parties to their local state groups, to individuals, to their candidates, and things like that, right? So there's this is kind of like the basis of the knowledge graph, and if you wanted to, you could extend this to way more detail as
totally
such, right? So,
I could imagine adding previous when there was discussions in the government or in votings on certain topics, then these results are available as well. So we could,
that's a really good point, Alex. So if you look at like past governments, you could put in, so for instance, the different eras. Then you can put in the coalitions that existed in the different times. Who was in opposition? Who was in the governing body in government? And then, for instance, you could also put in laws and how the different parties and people kind of voted for these different laws and how these laws are actually relating to topics, right? And you could do this on the global country level, but also on the state level, and then compare like state politics versus country politics and so on. So there's a lot of potential here what you could do, right? If the data is available, then it's easy to add more data to a graph like that. Right? Okay, cool. And so what would this look like? So we basically take this is our data. And what we also do is we create a bunch of indexes on party name and thesis, and then load the data. And for loading the data, we can just go to our GitHub page. There's it over here. And so first of all, we create a bunch of indexes and constraints. So we just create the constraints on the party IDs and topic IDs, and the indexes on party name and topic name.
Why are we doing this, Michael?
Okay, we are doing this for two reasons. So it's the graph database doesn't need indexes for things like joins or so, but it can benefit from indexes when looking up individual data points. So for instance, if I want to find a party by ID or topic by ID, for instance, to create the relationship between them, then this is much faster. It doesn't have to scan all the data, but it can just use the index to look this up. And for instance, party names is nice if you, for instance, if you had a larger data set, then it could quickly find the name, the party or topic by name as such. So for this kind of size of data set, it's not necessary, but it's actually good practice to do it like this. So so here we have our running database in Aura, and we can now say open with, and we can pick browser or Bloom. We start out with Neo4j Browser. And you have to put in your username, which is Neo4j, which it doesn't tell you, actually, which is kind of weird. But it's good to know that the username is Neo4j, and the password is the password that you saved before when you created the database. And if I now connect my browser to it, I get basically an empty database. There's nothing in there, and we can actually keep this open. And now create our indexes and constraints. So we just can paste this in, and it can actually do multi-element or multi-statement execution. So I click on run over here, and it just goes in there and creates indexes and constraints. And all the green check marks tell me it's all good. And If I click on any of these, then I see that these were successful. Okay, and now the interesting bit. So you already see it now created like placeholders for the party and topic. So we know, because the constraint exists, that this label for party and for topic should be in the database. So it's a little bit like an optional schema. So Neo4j itself is schema free, but with the constraints and things like that, you have a little bit of schema metadata, to say so, to hint at things. Okay, and then the interesting bit starts with loading the data. So what we can actually do, we can split this into 2 steps. So first I'll show you what the data looks like in Neo4j. So I can just say load CSV with headers from our URL. This is basically the CSV that I had over here. So you need to click on a raw, and then you get the raw URL for the CSV. And we can just get this and then say load CSV from this URL with headers as row. And then we can just return a row and say we do limit 5. So the first 5 rows of the CSV. So it grabs the CSV, downloads the data, and then you get each row of the CSV as a map or dictionary or hash, however you want to call it, or object, which has like the key is the header and the value is the value in the cell in the CSV, right? So, and what we now can do is basically take this information and turn it into our graph. So that means the first two things, like party, or the party name, party description, party number, we turn into party. The thesis we turn into the topic, and the position we turn into our relationship as such. Okay, and looking at this, this is kind of the whole input statement here for the file. It looks a little bit complex or more involved, and we'll go through this kind of line by line to see what this does. So it complains. What does it complain about? Oh yeah, so it complains that we should be careful that we have too much data, then we should use using pure periodic commit. But we have to batch the import, but actually, yeah. Anyway,
I think it's going to be fine in this case.
Yeah, it's fine. It's not for this kind of data sets. It's not important. So here is the bit that we just had, and then basically we take the party number as the ID for the party. So we merge. Merge is an operation that's get or create. So if the party already exists, it doesn't create it a second time. Where if I had create here instead of merge, then it would create one party node per row, which we don't want. So merge creates only one party node altogether. And you see that because the kind of headers are really this weird space, colon, dot thing, we need to backtick this so that it's escaped. So row dot, and then the header name. But we have to escape this with backticks, otherwise it would complain about it. And we set a text to the party name and the name to the short name. So because the party name is like the long bit and the short description is kind of just a 3-letter acronym, basically, as such. And for the topic, we do the same. The ID is the number, and then the text is, the name is what's in the title, and the text is the thesis itself. And then we basically create a position between the party and the topic. The text becomes just the explanation. And the weight is a little bit interesting because we need to take our position thing and then the textual thing. I agree. I don't agree, then it gets in 0. I agree, then it gets a 1, and neutral gets a 0.5. So we basically turn these 3 positions into values between 0 and 1. And then we just return the number of rows that were created in there. Okay. Any questions, Alex? Anything from you that you want to comment on?
No, I think that is fairly clear. Rodolfo asked how we created the schema, but I mean we looked into the earlier, or maybe you missed it. We looked into arrows and we had to look at the data in itself and saw, okay, exactly, here it is, and you say, okay, what kind of data do we have? We have parties, we have positions, we have a thesis, like Michael just said, and this is why This is why we came up with this. I mean, there are different other ways to do it, but I think this is the most straightforward version to go with this one.
Yeah.
No arrows does not create a schema. You do as a user. You look into your data, what makes most sense, and there is not necessarily a schema per se. It's more like a
implicit schema.
Implicit,
right? So
yes, yeah.
it comes from the data that you add to the database.
It depends a little bit what kind of questions you want to ask, and this kind of like baselines what kind of schema you create and how your data model looks like, and this and then, like Mikkel previously said, the position could be a separate node if this is something we want to query particularly differently, and then the model would look different, and then we would have so always you think about what kind of questions do I want to ask my data, and then this is how you model it, and then you implicitly create a schema for it, but you can always change that. So once after we have done this and we would have added more data, we could always say, okay, this is not working anymore. We need to refactor it a little bit, and then we could change that. So it's not as rigid as with other databases, maybe.
Yeah, it's kind of like whiteboarding, right? So imagine you have a problem that you want to solve with your colleagues, and then you basically grab a whiteboard. At least pre-COVID times, you grabbed a real whiteboard. Now it's probably grabbing virtual whiteboard, and then you say, okay, what kind of entities do I need to answer this question? What kind of relationships between those entities are important for answering these questions. I mean, there might be more entities and more relationships, but if they're not so relevant for answering your question, then you might leave them off, at least for the time being, right? So even if you have more data, it might not make sense to cram all the data into the database if you only need a subset of the model, for instance, for your particular use case or so, right? So then from that perspective, it's actually, it's interesting. Arrows also has a mode of creating interactively a model, basically from data, but I forgot how it exactly works. So perhaps that's something we can try out next time.
Maybe we try it next time, yeah.
Cool. So we haven't run our statement yet. So let's
maybe one more question came up from Konrad. Is case, is that an official part of Cypher, or is that
So case is an expression which actually, it's a good point. Cypher, you can also see it here in the help section of the browser. There's something called Cypher ref code, and which is super useful ref code of Cypher keywords and functions and expressions and so on. And then you'll find good examples of all the things. And so, for instance, if I search for case in here, then hopefully here's case. And it is an expression that basically, based on an condition, it returns different kinds of data. And either it has two modes: either you pass in the data and then it's kind of like a switch statement, basically, or you have case and then each expression is on its own line, and then basically it computes an result. Right?
You can always click on the heading for
and details. Exactly. If you click on the heading here, then it gets you to the docs page for this as well.
Super handy.
Yep, totally. What's important about case is you can't do operations within case. Case is really just a compute expression. That's important to remember. So it's not a conditional for doing different updates or so, but it's really just computing a value. Okay, cool. Now we ran our statement. It returned 1,444 rows. So that was the number of rows in the CSV. And now if you look at our database, it also says, oh, now I have position relationships here in parties and topics and 76 nodes and 1,400 relationships. So if I click on this position thing here, then I see a subset of the data in here. And if I look at one of these nodes, I see this has like ID, name, and the text. And here for the party, it has ID, name, and the text is basically long name. And if I click on the position, it has the text of the position and the weight. Right. So this is kind of the detailed explanation why they agree or disagree with a certain position. And then the weight is the interesting bit for us, at least. Right. And now you could use this this data in a graph database to basically build something similar like the interactive tool, right? So that's kind of one thing, because Neo4j is just a database, so you can just use JavaScript or React or mobile app and run this against your Neo4j database, right? And then you could either store the users' opinions in the database, or you just leave it as an read-only where the user just gets the local data and it's not stored anywhere. That's then up to you, right? So we have our data in the database, and now what can we do with this? Of course, we can find all the parties, all the topics. So, but it's not so very interesting. What I wanted to look at is kind of, can we explore this a little bit more in an interesting way? So, which gets us to Bloom, actually. Good point. Because, as Alex said before, Neo4j Aura doesn't just come with Browser, but also with Bloom, which is an interactive exploratory tool for Neo4j. For non-developers, especially, exactly. Right? So if you don't know anything about Neo4j's query language, or if you want to show this data to someone and want to have them explore this interactively, then you can give them like link to Bloom, and then they can explore this interactively. So for instance, I can just find all parties, and then it finds me all parties. Then I can look into those. I could, for instance, style them. So for instance, I can give these parties an icon or so. What's actually a party icon? I have no idea. People?
Maybe. Yeah.
And a topic could have like a tag icon. Where's a tag?
Yeah, this one looked like a little flag, maybe.
Like a tag. So,
like a
I
tag.
don't know. Right? Stuff like that. So you can style those, give them different colors and other things as well. And you can also do things based on attributes, right? So you can also color things by, for instance, by ID or by numeric attributes. So for instance, imagine you had the number of members in this party and you wanted to style the nodes based on the member count or something like that, right? Or what's actually new in Bloom recently, you can color it by rule-based colors by ID, and then you can say unique values, and then every party gets a different color. So if you just want to color them randomly so that you can just have distinct colors in there, then you can basically give them different colors. Or you can also assign colors yourself if you wanted to, right? So it's also possible. So this is also an option. If you just have a number of things that you want to color differently, then you can do this just to quickly discern them as such. But what's more interesting is actually if I take some of these parties here and say I want to expand this, so I can either I think I can just, when I double click, it shows me the details. I can also see the relationships of this party onto any other positions, and I can look at the neighbors as well. This is like this textual view of the data. But then I can say expand, and then I can either say I expand from one party to all its neighbors, which is the topics in this case.
The topics, yeah.
And then I can kind of continue to explore. For instance, I can say, okay, I want to explore the home office topic and want to see how all the other parties are related to that. And I can see this, right? And right now you can see that the position is kind of just a relationship, but fortunately we can also style these relationships, which is kind of nice. So what we can say now is we style this by weight. And we say we want to color it by weight from 0. Let's say if they don't agree, we want to give it a really lightweight.
Maybe a red color.
Or red. You can also pick red. So actually, that's a good question.
We need to scroll. Yeah, exactly.
Yeah. So if they disagree, we give them a red color. And then if they agree, we give them a green color, and if they are neutral, 0.5, we give them yellowish color, right? So it's kind of a traffic. Oops.
Yeah.
And selected the wrong one. I'll fix that in a second. So we give it like a yellowish color here, like this. And here we said with red, then we have to disagree, right?
Yeah.
So, and then what we could also do, we could also apply a size that kind of represents the weight or so, right? So, for instance, if I have 0 to n, I could have a really thin line for 0 and a wide line for n, for instance, right? So, but this shows us actually really nicely if people or parties agree or disagree with a certain position. So I can immediately see, okay, this party seems to disagree with a number of these positions and has only a few things that they agree with, and other parties have other things, right? So which is interesting. So let me just quickly clear the scene, and I could say, for instance, party topic party. So this is kind of how you can in Bloom you can query just by entering keywords, and it tries to infer what you want to do. And for instance, here it says you want to see these this pattern. But what you can actually also do, you can also say party. I think that's.
You
I think is it
you wrote party. You had a typo.
Oh, party. That's
yeah.
why. I think. Should I actually book party name? That's weird. Oh, probably party has name, yes, caption. So it should actually work. I don't know. Not sure what I'm doing wrong. Anyway, we'll check this out and figure it out for next time. So, for instance, we can look at these patterns, and Bloom, because it uses WebGL, can also use look at really large volumes of data. Let's see if this works. Loading the data from our instance.
Yeah, now it's loading all of it.
Yeah, exactly. Yeah. So that's what I wanted to show, actually. Come on, you can do it. Sure what is.
Give it a few seconds more.
So actually, it should not take very long. Not sure what's happening here. Come on, it's not so much data. It's weird.
Maybe that's why it was struggling with finding the name.
Something seems to be off a little bit. Anyway, while we're waiting for this, in the background, I had prepared a bunch of exploration queries. So, for instance, what we can do is we can take the top first 6 parties, which are also the main parties, and look at their positions, but only if they agree with the position and if the weight is 1. So this is kind of the query language. I have a party, the position, and then we can access the variable for the party here. We say the ID of the party needs to be equal or less than 6. And I just take the first 10 theses so that we don't have too much data here to show, but only those where the weight is 1. Right? So if I run this statement, I see all these parties and 10 theses, as you can see, right? And their positions. But actually, it shows too many of those. And this is actually a good thing to know. Neo4j Browser by default tries to pull all the relationships between the nodes that you returned, which is configured by this connect result nodes thing over here. So if I disable this and rerun this, then I see actually only the relationships where there's a 1 on the ID on the weight, right? And now we can actually.
So earlier it also checked it included the ones where it did this.
Exactly. So browser basically pulled all of them, right? So and now we can basically look at okay, how do these parties basically cluster between these topics, right? So you can see like the conservatives here are having a similar agreement to certain things. The right-wing nationalist party over here on the right side, and then the left green progressives are here agreeing on those topics, right? So you see that jointly agreement on topics is kind of already clustering these parties, which is interesting, which is something that we can actually look at. Right? Okay. So, and you can also see here in browser, you can do full screen, you can zoom in and things like that. So that's quite nice to explore things. And from here, I could now actually expand any of those links as well. So if I want to interactively explore stuff here, then it would also be possible. So the other thing that I wanted to show is, can we actually look at how similar parties are? Oh, here it pulled all the data. So I don't know why it took so long. So this is 14,000 relationships or so. No, 950 relationships and 63 nodes, right? So it's not a lot of nodes, but it's a lot of relationships, right? So what Bloom offers is we can do filters here. So for instance, we can say I want to filter positions that are where the weight is only 1. Right? And if I then apply the filter, it grays out all the ones that are not 1. So you see that all the yellow and red ones are gone, right? If I remove the filter, they come back. So I can gray them out, but I can also say I want to just remove all of them. So it basically removed all the, dismissed all of them, right? So it's not really removed. It's not removed from the database.
Hidden, basically.
Yeah, it's hidden from the visualization.
From the visualization.
But now we see basically that it's we see these are only the 1 relationships, so they should be clustering a little bit. So, but it's probably too many theses so that you can't see the clustering so well. And so you have certain parties that kind of agree with certain points, and the clustering should be more obvious. But probably we have too many small parties that kind of are messing up the bit a little bit. But we can add another filter. I just realized this. We can just add another filter that says, I just want to see the parties whose ID is, let's say, less than or equal and less than 6. It's basically the same that we had before, right? So it grays these out, and then we can remove these
what we
parties.
just did in
Right?
browser.
But this time with all the topics, right? Not just the 10 topics, but all the topics, basically, right? And now let's just relay out this real quickly. So now we should see a clustering of parties as well, right? So this is kind of the progressives again, the liberals, conservatives, and the nationalist party. Right, so you see a kind of clustering based on the graph visualization as well.
Mm-hmm.
But we can actually do better than this, which is our next example here, where we can actually look at the differences between parties. So we take a party, their position to a topic, and then a second party and their position to a topic, right? So where it's not the same party, and then we basically just return the delta between their stances and sum them up, right? So we say, okay, if the parties have the same stance, then the difference between them is 0, right? And the more zeros there are, the more similar are these parties, right? If they have a difference between a stance of 1, then they disagree. If it's 0.5, then they basically have a half agreement on that, right? And so we can either sum them up or compute the average. And if we run this, we actually see really interesting that just looking at the graph data, we can just see how similar parties are, right? And this is kind of similarities between left parties. Then you have similarities between right-wing parties here as well. And at the end, where we see the dissimilarities, if you go all the way to the end, then we see also that between progressives and nationalists, there's a massive difference, right? So there's an almost complete disagreement on topics, right? So so the parties here at the end, like rows 700 something, show how different parties are, right?
Mm-hmm.
So this is really interesting to see. So even just looking at the graph data, right, even without knowing anything about the domain and without knowing anything about like the political landscape of Germany, just looking at this data shows us already what kind of groupings or clusters similarities are there. And what we can do now with this data is actually we can create relationships, additional relationships, and that's kind of an enrichment of the data. So what we say, again, it's basically the same thing that we had before. Give us the parties, give us the average distance between these parties. And when the distance is less than 0.3, so 1/3, then we create a relationship. So we don't create a relationship between all the parties, but a similarity relationship for if they are like in 1/3 in the lower third or in the upper 66% basically of agreements. And then we set the weight to 1 minus the distance, so it's kind of more dissimilarity, right? So the distance goes from 0 to 1, and this is kind of the inverse. The similarity is the inverse of the distance. So we basically create a relationship between these two parties. And with merge, it will also just create one relationship between the parties. If there was already one, it won't create another one. And if you do this now, it creates 151 relationships. And then now we see that now there should be like a similar relationship popping up in a second or two here. Let's see if it does this. And which gives us basically a clustering of these parties by similarity. Why doesn't it show these? That's weird. So, but while browser is thinking about refreshing, we can actually look at these in blue.
I guess you need to refresh.
Yeah. So we can say party is similar party.
I think you need to need to refresh data before it does it.
So there's also refresh perspective, refresh. So party.
Now it is here, I guess. Yeah.
Similar party. So it has this pattern. And if I pull this information, then I see these clusters here. Right? I already did some kind of styling of these similar relationships. So if you want to do this, you can go on the relationship itself and say, I want to style the weight in terms of color. I can say from this min value to max value and give it kind of a different level of green. And then I can also style the size where I say, okay, the lowest value gets in 0.5 strong, so very thin line, and the strongest gets in 4x. So the bold lines here are strong.
Very similar parties, basically.
Similar, exactly. So you see that kind of the progressives have a pretty strong relationship here. Then you have, this is like the right wing party landscape in Germany. Oops. And then down here we have the nationalists and the conservatives and liberals are a little bit by themselves. So this is really just the parties that are very similar to each other, right? So these similarities we kind of captured here. And so this was an example of how we can enrich the graph data, basically to take data that we already have in a graph or from an external source to add more relationships to it. So then we can say, okay, now we can enhance this as such, right? And with something like graph data science, you could go even steps further by running clustering algorithms and things like that. But you can also do this even without graph data science as such. So this is kind of the level of what I wanted to show today in terms of what we can do with this data. Of course, we can connect now to our Aura instance as well. So if I want to, I can click here on the connect button and say, okay, I want to use Python, for instance, in a Python notebook or so, want to connect to my Aura instance. And here's an example. Or with JavaScript for building a front-end app or building GraphQL API against this database, or with Java.NET or Go right? So if you want to kind of start building an app against this, then you can have here some examples on how to get started with those as well.
Very cool.
So I think that's it from my side in terms of exploration of this data set. So as we said, discussed in the beginning, we can go much further and do more pulling more data in from past governments and state data and so on. But this is just scratching the surface basically of this.
No, but I think that's good. One more question from Conrad. Can Arrow generate cipher statements that we can enter in the browser?
Yes, that's a pretty great question.
We can show that.
So here we have our data model. And if you really do an instance-based model, so for instance, if I would say here ID5 Name Grüne, and I would say die Grünen, and I would say speed limit is I can actually turn this into a property as well, but I forgot how it worked. So ID1 and then speed limit, and would say here my weight is 1. Then I can say download export, and then it's a cipher here, and then would say create party ID5 Name Grüne description, this position, weight 1 to this topic, so I can run this in my browser as well. You can even interactively run this as well, and you can say I want to merge this instead, then it would create a merge statement instead. But this works best when you use this example-based approach, right? So when you don't do just a model thing where you say just the types, but when you have examples of data, then this is quite nice.
Yeah.
Such. Right? But you can also export PNGs and SVGs and all kinds of other
exactly. Yeah.
GraphQL type system types, so that also works.
Absolutely. No, there's lots of opportunities and possibilities here.
Yeah, you can also style arrows with different themes
exactly.
and stuff like that. So there's a lot of good stuff that you can do.
Yeah, it's worth playing around with it some and exploring it.
Yeah. The only tricky bit is that you need to remember to pull out relationships from the halo of a node. So that's the only thing that beginners sometimes struggle with. But otherwise, it's a really good tool for creating good graph drawings, basically, as well in graph models, right? So it has a lot of.
I think for modeling, this is the tool, because it's really easy to change stuff, to rearrange things. To when you start with a model, you draw your first couple of nodes, and then you label them, and you add your relationships between the nodes. It's really visual, it's really clear, and then once you have that, you understand. Like you said, you start with a whiteboard, you discuss with a couple of people, maybe ideally, and then once you have, okay, this is our baseline, this is what we wanted to do, this will answer our questions we have for our data, this is what we have to connect our various data points, and then get us into Neo4j is such a great start. So helpful.
Yeah. And as we said, you can find the all the data from today and the query and the statements all in the repo.
Exactly.
So
everything's there, all the previous sessions as well. So if you want to catch up on those, you are welcome to do so.
Already on week 7 now. So
exactly. Yeah.
So Alex and Lou have done a good, amazing job covering lots of data.
A few things. We will be back next week with another set, another fun discussion. Thank you all for joining us today. It was a great session. Thank you, Michael, for showing us through.
Happy to. Yeah, but next week is in later in the day. It's in the afternoon, so that Europe and US folks are benefiting. So we try to alternate the times going forward. So that's 1 week is in our morning and your afternoon or so, and the other week is in more US friendly time zone. So
exactly. This is more for APAC and Asia. Europe. The other one is more for yes. So Conrad, you don't have to stay up late.
Cool.
All right. Well, then take care, everybody. Have a good week. We hope to see you soon. Reach us on Twitter and all the other channels if you have suggestions for data sets. And we would like to explore them with you together. Otherwise, take care and see you soon.
Take care, everyone. Bye-bye.
Bye.